Hello student, here I have given the solution of block diagram reduction problem. Okay, so see the solution. This is our first problem. Okay, so for first problem, how we will find the transfer function of this block diagram reduction. So this is our first the first problem. So in first case, what we will do, so in first step we move this take off point to the left of the block G2, okay, and split this 3 input summing point into 2 input summing point. Okay, so after that, in the next step, what we will do, we eliminate the feedback loop, this and combine this parallel block. Okay, so after eliminating these two feedback loop and combine the parallel block, we get this structure. Now we combine all cascade connection. This is 1, this is 2, and this is 3. That means we multiply these 3 block, gain of these 3 block. After multiplying these 3 block, we get the gain is this. Now this is our simple feedback loop. So after eliminating this feedback loop, we get this. This is our transfer function. This is C by R. So this is our transfer function. Okay. Now come to the next problem. This is our next problem. Okay, so what we will do in this case, so first we shift this take off point from here to here. Okay, that means this position from here to here. Okay, and after that we eliminate this summing block. Okay, so if we eliminate this summing block, then these two gain are adding. Okay, so these two gain are adding here. So after that we move this take off point from here to here. Okay, after moving this take off point from here to here, we get this type of structure. Then eliminate this feedback loop. Okay, this is our one feedback loop. This feedback loop. So after eliminating this feedback loop, we get these two block are cascade in. These two block are connected in cascade. So multiply the gain of these two block. Okay. So after multiplying these two block, then we get a single block, and then this is our normal feedback structure. So after eliminating this feedback structure, we get this is our transfer function. So this is a C by R, and this C by R is G1 into G2 plus G1 into G3 divided by 1 plus G2 plus G3 plus G1 G2 H1. Okay. See, this is our third problem. So what we will do in this case, in first step, we shift the summing point before block G1 to a position after block G1. Means we shift this summing point from here to here. Okay. Then in next step, we interchange the consecutive summing points after block G1. Means we interchange these two summing point. Okay, and after interchanging these two summing point, we get this type of structure. Okay, now eliminating the summing point after block G1. So after eliminating this summing point, these two gain are at. Okay, so we get this. So after that, what we will do, we shift this summing point from here to here, okay, and after doing this, we get, this is the gain of the block, because if we move this summing point from here to here, then these two blocks are connected in cascade. So multiply the gain of this block. So after multiplying the gain of this block, we get, this is the gain of the block. And this is our simple feedback structure. So after eliminating this feedback structure, we get, this is our transfer function. Okay, clear? This is our problem number 4. So what we will find, how we will find the transfer function of this block diagram. Okay, so first we move the summing point after block H2, means we move this summing point from here to here, okay, H2, and combine parallel blocks G2 and G3, means combine these two blocks G2 and G3, okay. So after move the summing point, so after moving the summing point after block H2 and combine parallel block G2 and G3, we get first. So after combining the cascading block, means these two, means this here highlighted the cascading block G1 and G2 plus G3 are one cascade connection, and H2 and H1 are second cascade connection. Okay, so combine these cascading blocks, we interchange the summing point. We interchange the summing block. Here only two summing points are there. Okay, so interchange the summing point after cascading, we interchange the summing point. So after interchanging the summing point, we get this type of structure. Okay, so now here see, this is our parallel connection. So after parallel, so after eliminating this summing point, we get this block, and this is our feedback connection. So after eliminating this feedback loop, we get this. Now these two are connected in series, so we multiply the gain of this block. So this is our transfer function, CS by RS equal to 1 plus G4 into H2 in one first bracket, and second first bracket G2 plus G3, and this two first bracket is multiplied by the gain G1. In the denominator there is 1 plus G1 H1 H2 into G2 plus G3. Okay, clear? Now come to the fifth problem. This is our fifth problem. Okay, so how we will find the transfer function of this block diagram? So in first step, we split the 3 input summing point, means we split this summing point and move the takeoff point after block G3, means we move this takeoff point from here to here. Okay, so doing this first step, we get this structure, this first one. Okay, next step is, after that, next step is combine the cascading block G2 and G3. Okay, and eliminate the feedback loop, here indicated by highlighted portion. Okay, so first in second step, what we will do, we combine this cascade block G2 G3 and eliminate the feedback loop. So after doing this step, what we will do, then again we cascade these two block, okay. After doing this step, then what we will do, we add these 3 feedback loop, means here one feedback, second feedback, third feedback. So we add this gain of the feedback. Okay, so after adding the gain of the feedback, we get this 1 plus h1 plus h2 divided by h3, and this is our gain, forward path gain, and this is our feedback loop. So now we eliminate this feedback loop. After eliminating this feedback loop, we get this is our transfer function. Okay, okay. Now come to the sixth problem. So this is our sixth problem. So what we will do in this case? First, shift the takeoff point placed before block G2, means we want to shift this takeoff point from here to here. Okay. Then we see these two blocks are connected in parallel. Okay. So we eliminate this summing point by combining these two blocks. Okay. So after shifting the takeoff point and combining the parallel blocks, we get this structure, this second one. Okay. Now you have seen G1 and G2. This G1 and G2 are connected in series. Okay. So we multiply the gain G1 and G2. Okay. So here we multiply the gain G1 and G2. Okay. And these two are also connected in series. So we multiply this G6 into G3 plus G4. Okay. And next so after cascading G6 into G3 plus G4, then this G5 means this G5 by G2 and this G6 into G3 plus G4 are connected in they are connected in parallel combination. Okay, parallel combination. So these are added. So here we get this G5 by G2 plus G6 into G3 plus G4. Okay. Now these two are connected in cascade. So this H1 is multiplied with this gain block. Okay. So after multiplying H1 into with this gain block, we get this type of structure. Okay. So come to the next. Now we split this summing point. Okay. So split this summing point, we get this structure, the first one. Okay. So here we have seen there is two feedback loops. So after removing first feedback loop, means upper one, we get this is the gain of the block. Now we remove this second feedback loop. So after removing the second feedback loop, we get this is our transfer function. This is our transfer function. C by 4 equal to G1 by G2 divided by 1 plus G1 into G2 into H2 plus G1 into G5 into H1 plus G1, G2, G3, G6, H1 plus G1, G2, G4, G6, H1. Okay. So here I have discussed all the problem which I have given in previous class. So now you will do this problem. Okay, to see the problem, here we use two input. That means here this is one input and this is other input. That means here we add disturbance. So how we will find the transfer function in this type of block diagram? So first, so in this case first we put d equal to 0. Okay, so first we put d equal to 0, then solve the transfer function. That means c by r, find the transfer function c by r. And in the next step we put r equal to 0, and find the transfer function c by d, because in this case d is the, in second case d is the input. So find the transfer c by d, and after that means after finding c by r and c by d, then we add this c by r plus c by d. Okay, so you people will do this problem. Okay, so thank you.